So hello and welcome friends to our channel Intro Mech, where we discuss about basic mechanical engineering concepts and many other things which are related to industrial automation field. So guys, we have started our new series related to industrial robots, and we have started looking into different robot configurations. So today we will focus on cylindrical and polar configuration of the robot. So without wasting time, let's get started. Now here on the screen you can see this image. So are you able to identify what are the different motions it will have? So this O indicates the orthogonal movement, L is the linear movement, and this is a twisting movement. So this cylindrical robot is made up of primary arm that moves up and down. The arm contains the cylinder that creates the motion by extending and retracting itself. The arm's rotation is generated by the gears, and it will be having some motor. So the cylindrical robots are commonly used in, let's say, spot welding, die casting, palletizing, and they are having different kind of applications. So here you can see how it is having the motion up and down. It is moving, it is rotating, and this is moving in and out. So this moment is rotational, then coordinate system is cylindrical. That's how it is called as cylindrical robot. Then the work volume, we will see the joints it is having a rotary and linear joints. So work envelope, as we discussed, the work envelope configuration suggests the work envelope volume type also. So it will be like a cylinder. So here you can see the horizontal stroke, the vertical reach, and this will show the its work envelope. So it creates the cylindrical dead zone around the robot structure. So it will be having a dead zone, and the cylinder is hollow since there is a limit to how far the arm can be retracted, and that's how it creates a dead zone around the robot structure. So it will be having a dead zone in which the arms cannot operate. So we need to check this dead zone, and we need to check only the working zone in which we can place our end of arm tooling. So that is important. So when should we use the cylindrical robot? So it offers some of the unique features like a task simplicity. If the task is very simple and we need a compact and cost sensitive solution, then we can think of the cylindrical robot, as it has less number of joints, the cost is less, and also it is a compact solution. So this is where we can use the cylindrical configuration, although it is having a limited number of applications, as different type of configurations are available now, and those are widely used. So this is all about cylindrical robot configuration. Now let's learn about spherical, which is also called as a polar configuration of the robot. So let's check it out. Now in the right hand side image, if you closely look, you can see the motions. So are you able to recognize the motions? So L indicates the linear motion, R is the rotational motion, T is the twisting motion. So the polar robots are also known as spherical robots and are characterized by their unique configuration and movement capabilities. So they perform three different movements like rotation, then elevation, and the extension. So rotation, elevation, and extension. So rotation, robot can rotate around a vertical axis which forms the base of the robot. So twisting, so it can like rotate. Then elevation, the robot's arm can move up and down in a vertical plane, enabling it to reach the different heights. So it can move up and down. And then the extension, the robot's arm can extend and retract, moving closer to further from the base. So these are the motions involved. So let's check out once more how it works. So you can see the motions. It's rotating, then move up and down, and the extension is there. So it is also called a spherical robot. It is having the movement, rotational movement coordinate system is polar. That's how it is called as a polar robot also. Then joints are rotational and linear, and work envelope we will check out. So this is the work envelope. We know the working envelope of this configuration forms a volume between the two partial spheres. So here we can see what is the work envelope. So this is the work envelope for polar coordinate robots or polar or spherical robots. So there are physical limits imposed by the design on the amount of angular movement in both the vertical and horizontal planes. So these restrictions create the conical dead zone both above and below the robot structure. So as we saw, like in the cylindrical robot also, they will be creating a dead zone, and the dead zone is nothing but the restricted space. So we need to check the dead zone for the robot, because this is the zone where robot cannot operate. So if you design something for the movement of the robot in this place, it will get fail. So that's how the dead zone is very important, and what is the exact available working space that is required. So this is the work envelope. So when should we use the polar spherical robots? What are its unique advantage? So they have large workspace. So polar robots have broad work envelope because of the spherical coordinate system. So this is one kind of advantage. Then they have the efficiency in circular motion task. So they can be uh, they, that's why they are ideal for palletizing welding applications. And then the precision and repeatability. So they have good accuracy and good repeatability with the minimum variance. So that's why they are ideal for tasks which require high precision. So applications like in automotive, aerospace, welding, injection molding, these kind of robots are used. So guys, we learned about cylindrical robot and spherical robot. So this is kind of a summary what we just learned about the cylindrical and spherical robot. So structure, we have like rotary and prismatic joint for cylindrical, and for spherical we have rotary joint with an arm extending in an arc. Then degrees of freedom, if we talk about, then both have 3 degrees of freedom, but cylindrical have one rotary and two prismatic, while spherical has two rotary and one prismatic. Work envelope, it is cylindrical, like a hollow tube or a barrel shape. As we saw, it creates a dead space. Then it's a spherical, it's like a ball or dome, and it is also having a dead space. Reach, it can extend it vertically and radially, it can extend it in all spherical direction. Then we have base moment, then it is best suited for tasks requiring vertical stacking or cylindrical access areas, and this is spherical robot are best suited for the task requiring arc like sweeping motion or wide angle reach. Then work space shape, as we saw already, like open cylinder, and it is a partial or full sphere. Complexity is moderate and it is high due to spherical kinematics. And then ease of control, it is easier to due to simple geometry, and this is more complex due to multiple rotational joints. So this is like a summary of what we learned about cylindrical and spherical robots. So this is it guys for our today's session, and if you have any doubts, please do write into the comment section and we can discuss over there. Until then, keep intro making. Thank you for your patient listening. Thank you.